Welcome to Math Proofs. My name is Adiyoja, and today we are going to be talking about the Pythagorean theorem. Now, this is a theorem or equation that you find all the time in geometry class, but you may not know where it comes from. So, simply put, if you have a right triangle, that is a triangle where one of the angles is 90 degrees, and you label the two shorter legs A and B, and the longest side, the hypotenuse, C, then the Pythagorean theorem states that a squared plus b squared will equal c squared. And this is a very, well, not intuitive equation. You wouldn't look at a triangle and say, oh yeah, a squared plus b squared is c squared. But for some reason, this is what the equation turns out to be. So in this video, we're going to be going over the proof of this. And before we can get into the proof, there's one major topic that you need to understand. Similar triangles. Now, when two triangles are similar, like these two right here, it means that while they may have the same angles, A and E have the same angle, C and G have the same angle, even B and F have the same angle. While they have the same angle measures, they may not have the same side lengths. As you can see, triangle EFG is clearly smaller than ABC. So mathematically, we would represent that these two triangles are similar by stating that triangle ABC is similar to triangle EFG. Now, when I'm going to be writing similarity in this video, I'm going to be going in order of angles. So if you see, I went from A to B to C. I went from the 90 degree to the double line to the single line. Same thing with the other smaller triangle. I went from E to F to G, 90 to double line to single line. So I'm going to be writing it like that in this video so that you can understand the similarity. Now, there's a few properties that are associated with this. If we draw some side lengths on here for each triangle, noting that these variables are lowercase and different from the angle variables, we can say that A, which is opposite of the 90-degree angle on the first triangle, ABC, divided by E, the side opposite of the 90-degree angle on the other triangle, is the same thing. When you divide those two, it's equal to C, which is opposite of this single line on the first triangle, to G, which is opposite of the single line angle on the second triangle. And you can even extend this to B, which is opposite of the double line, and you guessed it, F, which is opposite of the double line on the second triangle. So this kind of equation is only possible when two triangles are similar. Now we're going to use this property to prove the Pythagorean theorem. So now let's get on to the proof. Here I have a right triangle similar to what you saw at the beginning of the video, and it has some side lengths A, B, and C. And what I'm going to do is I'm going to divide this triangle into two sections by drawing a line straight down here. And what this line is going to represent is another 90-degree angle. And therefore we'll have another point called D. And now you should see that we really have three triangles. We have this triangle outlined in black, A, B, C, D. But we also have a triangle outlined in red, going from C to D to B back to C. And I'm going to draw that triangle over here. So just to make things look similar, it still has this point B, it still has the point D, and the point C. This angle B is going to be the same between the black triangle and the red triangle. And D is going to have a 90-degree angle, much like how in the black triangle, C has a 90-degree angle. Now what about the side lengths? Well, this A goes from C to B, so from C to B on this other red triangle will also be A. And this bottom one, D to B, we're going to call this length R. And it's going to be represented by, well, an R. And we're not going to care about this other side length. Similarly, there's going to be a triangle going from C to D to A back to C, a blue triangle. I'll draw that triangle over here. And this triangle has a point A, a point D, and a point C. And let's say that angle A has 2 lines. Well, this angle A is also going to have 2 lines because it's the same. Angle D is going to be 90 degrees. Now let's move on to our sides. We have this side B that goes from A to C. So we'll have B that goes from A to C. And then we're going to have this bottom length over here, a part that we'll call S, that goes from A to D. Now before I move forward and talk about similarity, I'm going to delete some stuff inside this black triangle so it becomes easier to interpret it. Okay, so now we have our triangle set. Let's look at some similarities. So if you see between the black triangle and the red triangle, they both have the angle B. So we know that triangle B on the red, DC, must be similar to, on the black triangle, BC, because C is the 90-degree angle and D was the 90-degree angle with the red triangle, A. So again, these two triangles are similar because they have the same angles. And they both have angle B and they both have a 90-degree angle. So they are similar. Now let's look at our similarity statements that we can make. I'm going to start off by using A because I need an A squared. So I'm going to have A. Now, what is the side that corresponds to A on the black triangle? Well, you see that A on the red triangle is opposite of the 90-degree angle. On the black triangle, that side is C. So on the bottom here, I'm going to write A divided by C. Now let's look at the other side we have, R. Now, what is corresponding to R on the black triangle? Well, R is in between B and D, the one line angle and the 90-degree angle. So if we look between B, the one line angle, and C, the 90-degree angle, we get the side length A. A. So now we have a similarity statement, and we can now simplify it. Now I want to get the A's on top. I want this A on the bottom to go away. So I'm going to multiply both sides by A. But I also don't want this C to be on the bottom because I just want to have an A squared. So I'm going to multiply both sides by C. If we look to the left-hand side, the C's will cancel out and we get A times A is equal to the right-hand side, and the A's cancel out there, so we get R times C. I'm just going to rewrite this for simplicity as A squared is equal to C times R. And now we have one equation down using the similarity between the black triangle and the red triangle. And we're going to do a similar thing with the blue triangle. The blue triangle and the black triangle share the angle A. So I'm going to write that triangle ADC is similar to, you guessed it, triangle ACB. Now why am I going ACB? Well, ADB goes from the double line to 90 to C. On the black triangle, going from the double line, we go A, then the 90-degree angle, C, and then back down to B. So that's B. Now what similarity statements can I write? Well, I want a B squared, so I'm going to say B Now, what side corresponds to B on this triangle? Well, we already said that B is opposite of the 90-degree angle, and the side opposite of the 90-degree angle on the black triangle is C. Now, what is that equal to? We also have this side length S. So we have S on the blue triangle. Now, what corresponds to S on the black triangle? So when we look to our black triangle, we have A, the double angle, and C, the 90-degree angle. The side in between them is B. So on the bottom here, we're going to place B. Now I'm going to do the same things that I did over here. I want to get the B on the top, so I'm going to multiply both sides by B, and I'm also going to multiply both sides by C because I don't want the C to be on the bottom there. On the left-hand side, the C's will cancel, and I will have B times B. On the right-hand side, the B's will cancel, and I'm going to have S times C. So, simply, it's B squared is equal to C times S. Now we have two equations derived from using this right triangle, and now let's see what they lead us to. Well, let's do a squared plus b squared, because that's again what the Pythagorean theorem says. But what is that equal to? Well, we know that a squared is c times r, and b squared is c times s. And I can simplify this by factoring out a c, because this is equal to c times r plus s. And I was able to do that because both of these terms had a c multiplied to another number, so I could factor out that c and just add those terms together. Well, what is r plus s? Well, if you look back to our diagram, we see that r plus s has to equal c. R was this portion of c of the line, and s was the other portion of the line. So r plus s is equal to c. So we have c times c, and that is c squared. So in conclusion, a squared plus b squared is equal to c squared. I hope you enjoyed the video, and I'll see you next time.